So if I look at a curve here and I draw a secant line, remember a secant line connects 2 points. If the curve is below its secant line, then the curve is concave up, which is the opposite of the relationship for tangent lines, which can be confusing if we're not careful. And I can say that about this whole interval from whatever A is to whatever B is. So this curve is below its secant lines from A to B. And so what that tells me is that this curve is concave up on the interval AB. It matters, you want to put it at the endpoints of the interval that you're looking at. Here, your secant line would be inconclusive. You could not say that this is concave up or down from A to C. What you could say is this is concave down from A to B because the curve is below and the curve is concave up from B to C. But if it crosses and it has different behaviors, then you have to chop it up finally. You're absolutely right. So we talked about this happening at a number. We talked about it happening on an interval. So f of x is concave up on the interval from A to B if f of x is concave up at each point in that interval. So you can say something is concave up at a single point, which is just looking at tangent lines, or you can say it's concave up on a whole interval. And the same thing for concave down. When you talk about an interval, you're really talking about an infinite collection of points. So if the property holds for every point in that interval, you can say that the property holds on that interval.